Welcome to this explainer. Okay, let's be real for a second. The Cambridge Physics 0625 exam can sometimes feel like an absolute wasteland of tricky questions, just waiting to trip you up. But today, we are navigating that wasteland together, and we are going to claim your grade treasure. We are tackling one of the most foundational yet heavily misunderstood topics in the entire syllabus, moving in circles. Look, I see it all the time. Students walk into the exam room, they see a question about circular motion, and they completely freeze. Or worse, they just start vomiting raw physics facts onto the page without any analysis. Let's call that the Alex approach. Or maybe they take the Sam approach, where they rush through, completely missing what the command words are actually asking for. Today, we are putting an end to all of that. We aren't just going to memorize formulas. We are taking a concept-first approach. We're going to break down the key structure and the first principles explanation of this topic. If you're ready to master this from the ground up and build an exam strategy that actually works, you are in exactly the right place. Let's get into it. Here is our roadmap out of the wasteland today. We'll kick things off with the starter challenge to get your brain in gear. Then, we'll reveal the 4-step framework, which is basically your secret weapon. After that, we'll decode the physics vocabulary, explore real-world connections, show you exactly how to survive those nasty exam traps, and finally, lock it all in with a quick recall routine. Section 1. The starter challenge, making physics absolutely necessary. Okay, I want you to look at this question. What physical effect, measurement, or prediction depends entirely on understanding moving in circles? Really think about this for a second. I'll give you a moment. We don't just study circular motion because it's some random chapter forced upon us in a textbook. We study it because without it, our understanding of the literal universe breaks down. How do multi-million-dollar communication satellites stay in orbit instead of crashing back to Earth? Why doesn't a car carrying your family skid off a curved highway? What keeps electrons tethered moving around a nucleus? Posing this question right at the start makes the concept feel absolutely required. It's not just a decorative piece of memorization for a test. It is a fundamental, non-negotiable rule of how our reality operates. When you see a past paper question on this, I want you to remember that gravity, friction, and tension are the real-world actors holding our universe together. Now, this brilliantly illustrates a core pillar of our concept-first learning strategy. Formal language comes later. First, you have to reason through the unfamiliar. Think about our student archetype, Alex. Alex tries to memorize every single formula and definition without understanding the underlying concept. If we just threw equations at you right away, you'd end up like Alex, totally dependent on memorized wording. But exam questions are notoriously unpredictable, right? Cambridge examiners love to throw you into scenarios you've never seen before. By reasoning through the physical effects first, before we even touch a formula, you build true adaptable reasoning skills. You start to see the hidden patterns. And that is exactly what's going to save you when the exam throws a massive curveball your way. Moving into Section 2, the 4-step framework. This is what we call the gateway pattern. Moving in circles is actually a micro-gateway into a much bigger scientific pattern within the Forces in Motion chapter. The absolute crucial point here is how you structure your understanding, and more importantly, your exam answers. The top IGCSE answers, the ones getting the A stars, use this exact 4-step sequence. It's very similar to the Peel framework you might use in other subjects. Adapted for physics. Step 1, identify the quantity or phenomenon. That's your point. What are we actually looking at? Step 2, state the relationship involved. That's your evidence. How do the variables interact with each other? Step 3, explain the underlying physics. That is your explanation. What is the root cause? And step 4, connect to an observation or device. That's your link. Bring it back to reality. If you guide your learning and your writing through these 4 linked steps, you demonstrate to the examiner that you possess both deep theoretical understanding and the ability to apply it practically. Now, before we continue on to the next crucial step, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. We are putting out strategies like this all the time, and you do not want to miss them. All right, Section 3, bridging to physics vocabulary, taking it from the everyday to the formal. Notice the clear division we've mapped out here. On the left side, we start with everyday language and concrete examples, things you can actually see and feel. Imagine swinging a bucket of water on a rope around your head. You can feel the pull, right? You intuitively understand the speed. But then, and only when you are completely ready, we transition over to the right side, symbolic relationships and formal definitions. We carefully translate that everyday pull on the rope into the formal centripetal force. We translate the speed of the bucket into velocity vectors acting at a tangent to the circle. This is where students like Sam lose marks, rushing past the command words and mixing up everyday words with physics vocabulary. Introducing these symbols and formal definitions only after the concrete concept is understood ensures that the underlying physics actually makes sense to you, rather than just being a random soup of letters and Greek symbols. And when we do start using this formal language, we have to be ruthlessly precise. We're going to do a quick mental data scan right now. Imagine a complex physics graph showing an object's changing velocity. When you are dealing with graphs, do not just memorize the shapes. You need to stress what the slope, the area, the direction, or the shape means physically in the real world. A constantly changing direction means a constantly changing velocity, which means there's an acceleration even if the speed is steady. Secondly, whether you're looking at magnetic fields, gravitational forces, or subatomic particles, you must insist on a strict chain of cause and effect. Don't just list isolated facts. Think, A causes B, which results in C. A force acts towards the center, which causes a change in velocity, which results in a circular path. This chain of cause and effect is the absolute hallmark of a secure, top-tier physics explanation.
That brings us to Section 4, Real-World Connections, where you actually use this stuff.
I cannot overstate how expansive this microtopic is. The physics of moving in circles is absolutely critical in all of these diverse fields on the screen. We rely on it in basic laboratory experiments. We use it in heavy engineering and safety protocols. Think about civil engineers calculating the exact angle to bank the curves on a high-speed highway so cars don't fly off into a ditch. It is the backbone of global transport systems and the design of massive energy-generating wind turbines. It gives us global communications by keeping satellites perfectly positioned in orbit. It drives advanced medical technology, like centrifuges used to separate blood components in hospitals. And, of course, astronomy. It governs the motion of planets, moons, and entire galaxies. Circular motion is literally making the modern world spin. Stop scrolling for just 1 second. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries just by reframing how they look at these topics. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get back to the strategy. Here is why all those real-world examples matter for your specific exam. You cannot just know the math. To get the highest marks, you must be able to name at least one real situation and explain exactly why the physics helps us predict or improve outcomes in that scenario. This is a crucial exam requirement that so many people miss. Linking the core theoretical concept back to a practical observation, a specific experiment, or a working device is exactly what elevates your answer from an average B grade to a solid A star. It proves to the examiner that you aren't just reciting facts, but that you truly grasp the implications of the physics. Which leads us perfectly into Section 5, Surviving Exam Traps, Dodging the Pitfalls of the Wasteland. We are going to do a quick Find the Flaw exercise right now. Look at the left side. Here we have a classic weak answer. This usually happens when a student panics under the timer. They just quote a correct formula without explaining what the variables actually are. Or they list a process, but they completely fail to link it to a physical effect. A flawed paragraph might say, the car goes in a circle because of centripetal force and mass times velocity squared over radius. Wait, what? Where did the force come from? What is its effect? It's technically not completely wrong, but it is deeply incomplete. It bleeds marks. Now look at the right side. This is the secure answer. It follows the safest method possible, integrating the framework we discussed earlier: definition, relationship, explanation, and application. First, define the force at play, friction between the tires and the road. Second, state the relationship. This friction provides the centripetal force. Third, explain the effect. It causes a constant change in direction towards the center. Fourth, application. This allows the car to safely navigate the bend. If you use this structured method, you literally leave the examiner no choice but to award you full marks. I want you to listen to this stark warning straight from the examiner reports. Quote, "Giving an example without showing why it follows from the physics is a common weakness," unquote. Let that sink in. You can name a satellite orbiting the Earth all day long, but if you do not explicitly explain that the Earth's gravitational pull is providing the required centripetal force, and that this force is constantly changing the satellite's direction of travel without changing its speed, well, you've missed the mark entirely. The examiner will just put a red cross next to your brilliant example. Never, ever miss the cause and effect link. It is the glue that holds your grade together. Finally, Section 6, the quick recall routine. These are your ultimate revision prompts. Think of this as your personal cheat sheet for guaranteeing top marks. We talked earlier about a complete system, decoding command words, applying the Peel framework, and managing your time. Well, for any topic, especially moving in circles, speed and accuracy come from having these 4 golden revision prompts locked in your brain. I highly recommend writing these down right now. Number 1, what is the core idea? What's the foundational concept? Number 2, what changes physically in the system? Is it direction, speed, energy? Number 3, what quantity or graph visually shows this change? How do we measure it? And number 4, where is it used in the real world? If you can cover up your notes and do a speed writing drill, answering these 4 prompts aloud for the topic of circular motion in under 60 seconds, I guarantee you are ready for the most difficult short answer and structured questions on your exam. It completely removes the panic because you instantly know the framework the examiner is looking for. So I'll leave you with this final, provocative challenge. Can you explain the physics behind moving in circles using a clear, unbroken cause and effect chain right now? Don't just sit there and nod along. Actually try it. Apply those quick recall prompts immediately in your head. Push yourself to articulate the exact connection between force, direction, and practical application. If you can do that, you haven't just memorized physics, you have mastered it. Now listen to me carefully. Students who implement these exact physics strategies see an average improvement of 2 whole grade boundaries. But let's be honest, that only happens if they practice consistently with our weekly breakdowns. So here is your final reminder. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by while you struggle with the same old mistakes. Drop a comment below right now with your target grade for physics and tell me the biggest challenge you're currently facing in your revision. Our team reads and responds to every single comment. And don't forget to like and share this video with a study partner who needs to hear this. Ace the Exams, your Cambridge success starts here. Keep questioning the mechanics of the world around you, and I will see you in the next explainer.